Hi, these are the problems to go over for our homework on page 84. This is problem 3, and then problem 4 will be the next slide. So the vertex is right in the middle. So when we take a look, we notice we have an a value of -1, a b value that's missing, so it has to be 0, and a c value that's 4. So I'm going to go ahead and tell you that it's opening down because that's negative, and then take a look at it. We're going to go x equals -b over 2a, which is -0 over 2 times -1. Well, 0 on top just means it's 0. So my vertex is going to take place right there. My axis of symmetry goes right up and down the y-axis. There's my axis of symmetry. Okay, realize my vertex lives along that, so we're going to find this value right here. So if we take 0 and plug it back into our original, now notice the negative's outside, but that's fine. It's not going to affect us. So that's just going to give us y equals 4. So 0, comma 4, 2, 3, 4 is right there. Okay, so now this becomes a little weird to think about. So I'm going to go one to the right and one to the left. Okay, so here's where it's going to get a little tricky. So I have y equals negative. That negative is going to stay there. Okay, I'm not going to put that in parentheses. So that becomes -1 plus 4, which is 3. So 1, 3, and 1, -3. And then we could plug in 2 and -2. And again, if I plug that in, I get y equals the -2 squared plus 4. So y equals -4 plus 4, which is 0. Guess what I just found right there and right there? Those are my roots. Here's my parabola. Okay, so will the parabola open up or down? Well, we have it opening down, so the answer to A is right there. Letter B says use -b over 2a to get the vertex, so my vertex is right here. Letter C, give the equation of the axis of symmetry, and the axis of symmetry is right here. Letter D, find any roots. We found roots. That is a root, so that's 2 comma 0, and that's a root. That's -2 comma 0. Complete the table. We have that completed, and sketch the graph. We're all done. Problem number 4. So we know that this is going to open down because my a value is negative. So my a is -3, my b is 12, my c is equal to -7. So let's go ahead and use x equals -b over 2a. Plug in our values, -12 over 2 times -3. That's going to be -12 over -6. So x equals 2. That's my axis of symmetry. So right down this line right here. Okay. It also tells me my x component of my vertex. In order to find the y component of my vertex, I'm going to plug that 2 into my original equation, where the parentheses are is where the x's used to live. I came from here and here. Now I'm going to plug 2 in. Okay, 2 squared is 12, or 4. 4 times -3 is -12. 12 times 2 is 24, minus 7. So if I combine those, that's going to give me 12 minus 7, so I get 5. So 2, 5 is my vertex. 1, 2, 3, 4, 5. It's right there. There's my vertex. Okay, so we know where it's going to cross the y-axis. Y-axis is 0 comma c. So in this case, it's going to be 0, -7. So 1, 2, 3, 4, 5, 6, 7. There's -7 down there. Okay, so realize I'm 2 away, so I'm going to go 2 away this way. And that's going to put me at 1, 2, 3, 4. So those are 2 away. So to the left, 0, -7. To the right, 4, -7. All right, now let's plug a value in here. So a 1 would go here and a 3 is going to go there. So I'll just take that 1 and plug it into our equation. So that's 1 squared is 1 times negative 3 is negative 3 plus 12 minus 7. So that's going to give me 9. 9 minus 7 is 2. Okay. So 1 comma 2 is right there. And 3 comma 2 is right there. Here's my parabola. Okay, we answer the questions. Does it open up or down? Opens down. That's my axis of symmetry. Any roots? Okay, so I know that the roots do exist there, but my dots didn't fall on that. So we don't know what these will be yet, but future classes will tell us where those roots will exist, okay? So don't worry about them yet. All right, so now we're going to kind of go quickly through these. This is from page I wanted you to try. This is page 87. We're going to go quickly. So the domain of every parabola we're going to work with in our class will be negative infinity to positive infinity. I always like listing the vertex. So my vertex here is going to be, I believe it's negative 2, and then 1, 2, 3, negative 2, negative 5. Okay, so the range, I need to look at that value. So the range, the bottommost value is negative 5. I'm going to have a square bracket because it's a point, and it goes all the way to infinity. This is the lowest point. Our vertex is the lowest point. So we have a minimum, and our minimum is the y value, so negative 5 of the vertex. There are roots that do exist, but I look back at the graph, and I can't see the exact values. So we're just going to, these are not known exactly right now. Later classes will find it for us. We did find the vertex at negative 2, negative 5. Axis of symmetry is always x equals the x part of the vertex, so x equals negative 2. And then we want to see where this is increasing. Increasing, I thought I made that red. Increasing means it's going up. As I go to the right, it's going up. Okay, so that part is all increasing. So it starts increasing. Talk about the x value. So soft bracket negative 2, because right exactly at that vertex, it's not increasing or decreasing. And it's increasing all the way to infinity. And then we want to know where this thing is positive. So let's find a nice color. I think go with a nice pink would be nice. Okay, where is it positive? It's positive here. That means it's above the x-axis. And it's also positive here. Now the hard thing is, because we couldn't find the roots, we don't know exactly where. So we're just going to make our best guess. So it's positive from negative infinity. And if I look at it, it looks like it's about negative 4.1. I'm just estimating. I don't think it might is that. And it's also increasing. If I look at my other crossing, that's like 0.2 to infinity. Positive means it's above the x-axis. Okay. Problem number 2. Well, our domain for all of our parabolas will be negative to positive infinity. Our range, this way, because it's upside down, is coming from negative infinity because I go bottom to top, and it goes all the way up to 0. That's a hard bracket. That is a maximum value. It's a maximum value, and our maximum value is the y value. Do we have any roots? We actually do. We have a root at 0, 0. That's the only root. It's where the vertex is, but that's okay. Remember, the root has to have a y value of 0. So our vertex is the exact same thing. Our axis of symmetry is x equals the x component of the vertex. And where is this graph increasing? Well, it's increasing here. So as I go to the right, it goes up. So it's increasing from negative infinity, coming from the left, all the way to 0. And it's a soft bracket. That's where it's increasing. And where is this graph positive? So positive means above the x-axis. And this one is not. It's not positive anywhere. It's not above the x-axis, and that's okay. All right, problem number 3, the domain, negative to positive infinity. range, we're going to use the y value. So the range is going to go from hard bracket 0 to infinity because it's opening up. My vertex is at a minimum. It's the lowest part. So what's my y value? 0. Do I have any roots? Yeah, my roots have to be 1 comma 0 because that's where it kisses it. It also is where my vertex exists. And then my axis of symmetry is always x equals the x value of the vertex. Where is this increasing? Well, it's increasing here. Okay, so we're going to use the x, so from 1 to infinity. And where is this graph positive? This is a mean question because that exact point right there, it's not positive or negative, it's 0. So it's going from negative infinity to 1, soft bracket, and then a soft bracket again from 1 to infinity. Okay, that's pretty mean because there's only one point that it's not above. It's on it, but it's not positive because that's a 0. All right, problem number 4, our domain, negative to positive infinity. Our range, we're going bottom to top, so from negative infinity to 4, square bracket, because that's a point. That is a maximum, and our max value is 4. It's always the y value. Do we have some roots? Yeah, I got a root there and a root there. So my roots are, looks like at 1, 2, negative 3, 0, and 1 comma 0. I happen to have a vertex of negative 1 comma 4. Axis of symmetry is always the x value of that. And where is this increasing? Well, it's increasing here. As I go to the right, it's going up. So it's increasing from negative infinity from the left all the way to negative 1, and that's a soft bracket. Where is this graph positive? It's positive. This is where it's positive. Anywhere above the x-axis. So that whole region right there. So you just label the x values that they are, which were your roots. So it's positive from negative 3 to 1. That is not a point. It is the interval notation. This is the interval notation. Okay, to write the... Okay, oh, I skipped one. Okay, problem number 5, domain, negative to positive infinity. Range goes from 3, bottom to top, to infinity. That is a minimum value. Our vertex is a minimum. What's the minimum value? It's the y component of my vertex. Roots, not real. It didn't cross the x-axis at all, so it's not real. It's not part of the real number system. I have a vertex at 0, 3. I have an axis of symmetry, which happens to be x equals 0. And then where is this increasing? It's increasing from the vertex to here. As I go to the right, it goes up. So it's increasing from soft bracket 0 to infinity. As I go to the right, it continues to go up. Where is this graph positive? Well, everything about this graph is above the x-axis. So it's positive from negative infinity to positive infinity. Okay, problem number 6, domain, negative infinity to positive infinity. Let's see, what's that vertex? 1, 2, 3, 4. So that looks like 4, negative 1. Okay, so my range goes from negative 1, hard bracket because it's a point, all the way to infinity. That is a minimum value. That's my lowest point. So my lowest point of my vertex is negative 1. Do I have roots? Yeah, I have a root here and here, so that looks like 3 comma 0 and 5 comma 0. Okay, what's the vertex? Well, we have it labeled at 4, negative 1. Axis of symmetry is always the x component of my vertex. Where is this graph increasing? It's increasing right here. That's where it's increasing. So from 4, soft bracket, to infinity. As I go from 4 in the x direction to infinity, the graph is increasing. And where is our graph positive? Well, the graph is positive here and here. So it's from negative infinity to 3, and then from 5 to infinity. So that should help you with the homework problems. Okay, so now we need you to turn, and we're going to start something called pattern graphing. I think you might like this. We will now be on page 91. So let me go back to page 91. Okay, this is called the 1-3-5 rule. Okay, let's go to... Okay, so if I were to graph, I'm going to grow at 1-3-5. If I have an a value that's not 1, it's 1 times a, 3 times a, 5 times a, 7 times a, etc. That's going to make more sense here. Okay, so let's find the vertex only. So x equals negative b over 2a, where my a value is 1, my b value is negative 4, my c value is 3. This parabola opens up because that's positive. So I'm going to go x equals negative negative 4 over 2 times 1, which is 4 over 2, which is equal to 2. So x equals 2. That's my axis of symmetry. So bring that straight up and down. That's my axis of symmetry. Remember, the axis of symmetry is the x component of the vertex, so I get 2 comma something. So I want to find the vertex. So I'm going to plug that 2 into where I had x. So 2 squared is 4. Negative 4 times 2 is negative 8 plus 3. And do the arithmetic. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. So I have a vertex at 2, negative 1. Okay, I'm not going to do a table. I'm going to pattern graph. Okay, the pattern graph is going to be a times 1, 3, 5, etc. Now you don't have to do that much of it. What's my a value? Yeah, it's 1. So it's going to grow at 1, 3, 5. Now we know it's going up because our a value is positive. Watch this. Ready? From my vertex, I'm going to go right 1, up 1. I'm going to go left 1, up 1. That's my first set of points, and I can easily identify those points. From those new points, I'm going to go right 1, up 3, and left 1, up 3. And you have enough here to graph your parabola. You can identify those points very easily. I can see the vertex is 2, negative 1. The y-intercept is right here, so that's at 0, positive 3. Notice it's 0, comma c. Then I have roots at 1 and 3, comma 0. So the pattern graph works very well. It's a very valuable tool. Let's go a little bit further. Okay, I know that my a value is negative 3, my b value is 12, my c value is negative 9. This is going to go down because the a value is negative. And let's find negative b over 2a. So x equals negative b over 2a. So I'm going to go negative 12 over 2 times negative 3, which is negative 12 over negative 6, which gives me just 2. So I have an axis of symmetry at 2. Okay, so my vertex is going to live somewhere in there. So I know my vertex is going to be at 2 comma something. Well, let's take 2 and plug it in. So I get y equals negative 3 times, 2 will go in there, 12 times 2 minus 9. So let's plug the 2's in. 2 squared is 4. 4 times negative 3 is negative 12. 12 times 2 is 24 minus 9. So that's going to come out to be 3. So I get 2 comma 3. So 2 comma 3. 1, 2, 3. There's my vertex. Now we're going to pattern graph. Remember, the pattern graph is a times 1, 3, 5. What's my a value? Negative 3. So I'm going to go negative 3 times 1, 3, 5. And that's going to graph me at negative 3, negative 9, negative 15. All right, you know it's opening down. So I'm going to go from here. Now I'm going to go right 1 down, 1, 2, 3. And I'm going to go back to the dot. Left 1 down, 1, 2, 3. And then to get my second set of points, I'm going to go from those blue, I'm going to go right 1 down, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Do the same thing over here, down 9. And it all mirror images. And here's my parabola. Okay, it's done. Okay, so that should help you um, with the assignment. Give it a really good try. This is pretty fun to do. I'd like you to do page 93, and I'd like you to do 1 through 6. And you're going to be doing the pattern graphing, so see how you do. Okay, there's nothing on page 94, so don't worry about it. Thank you so much. Have a great day.